Let's look at a derivation of the ideal gas law, which will be used to solve a significant number of problems when we're studying gases. We'll start by looking at some of the previous proportions we've learned. So from Boyle's law, we know that volume is inversely proportional to pressure. We know that volume is directly proportional to temperature, and that it's also directly proportional to the number of moles. So if we combine these, we'll get this relationship here. Volume is proportional to moles, inversely proportional to pressure, and directly proportional to temperature. Now we also know from previous lessons that in order to change a proportion into an equation, we need to introduce a constant. And the constant that we're going to introduce here is R, which is the gas constant. Now if I clean this up a little bit, I can move my P over to the other side. So I have P times V is equal to RNT. And then traditionally we look at the ideal gas law as written, PV is equal to nRT. In order to use this, we're going to need to determine the value of our constant, or R. But what we will be able to do is work with any scenario where we have a changing pressure, volume, number of moles, or temperature. So to determine the value for R, what we need to do is look at a point that we do know. We know from Avogadro's hypothesis that at STP, or 1 atmosphere and 273 kelvins, 1 mole of any gas occupies 22.4 liters. When we look at our relationship of PV equals nRT, what we have here at this point is we have a pressure, we have a temperature, we have a number of moles, and we have a volume. So in this 5-variable equation, we know 4 of the variables, so we'll be able to rearrange and solve for our 5th variable, or R. If we sub into that relationship using the values from above and solve, we will be left with 8.314 kilopascals times liters over Kelvin moles. And so this is our value of our gas constant. Now, what's important to note is that you'll be using this constant to solve problems, but you generally won't be asked to solve for the R value. What we do need to consider are the units when we're studying or using the ideal gas law. So the ideal gas law, as we've discussed, includes 5 variables, PV, and RT. R is going to be a constant, and once we know which R value we're using, then we'll be able to be clear on what will the units be of the other variables. So first of all, remember that when we're studying gases, our temperature is always going to be in kelvins. Moles is expected, that there's no other unit to use. We're going to use the unit of mole when we are using the variable N. Now, when we're using the ideal gas law, we're going to need to make sure that our volume is always in liters. And when we use the value of 8.314 in our ideal gas law, our pressure will need to be reported in kilopascals. So this R value that we solved for previously is 8.314, and you can see that the units of R need to match the units of all of the other variables in the equation. Now, as you know, when you're studying gases, we don't always use kilopascals for our units of pressure. Kilopascals and atmospheres are the most common units of pressure to use. And so what we've done is we've also derived, using the same method as the previous slide, the R value for a pressure of 1 atmosphere. You can go back and try this out and see if you can get this value, we would be subbing in 1 atmosphere in place of 101.3 kilopascals. So when you want to use atmospheres for your pressure, this is going to be the R value that's going to be used. The best thing to do to use the ideal gas law is to make a list of the variables and then sub in and solve.